The broadcast is now starting. All attendees are in listen-only mode.
So do not unmute yourself. I will be doing from my end. Hello and welcome everyone. Thank you for joining us for today's webinar. My name is Monica Bachchan and I'm a founder of MetaLogic Projects Management Services. It is a maximum women staff organization. Now, why we call it women staff organization and again, because mining and steel is considered to be a man's job, which we are trying to break this mindsets. And through this initiative, I'm repeating this line again and again because our 80% of staff are women. Today, on 23rd December 2020, we are presenting you webinar on underground mining and Industry 4.0. Webinar sponsored by NFDC Limited and Vedanta Hindustan Zinc. This is our 23rd webinar during COVID-19 pandemic and the last webinar of 2020 year. Just a short housekeeping before we get started. If you have any question during the panel discussion, please type them into the question box in your go-to webinar control panel. I'll bring them up during the presentation, and we will also have time for questions at the end. Always mention your company name and organization which you are representing and who you would like to address your question to. We are also having some poll questions for the audience. Please remain active to participate in the polls at all the time. Before we start, I would like to give a brief about the session to you all. Industry 4.0 offers new possibilities to combine increased productivity and stimulating workplaces in a good work environment. Used correctly, digitalization can create attractive jobs in safe, controlled room environments, which provide space for the employees' full expertise and creativity. For the underground mining environment and ecosystem, Industry 4.0 will be blessing as it would not reduce cost and create safe working, but also shape the future for the mining industry, which is currently battling the environmental issues like forest and soil erosion. Today, our expert panelists are Dr. Mukesh Kumar, Director, Steel Research and Technology Mission of India, Mr. Biplob Chatterjee, Director and CEO Consulting at Geovale Services, Mr. Harsh Kumar, Partner Distribution and Industrial Sector IBM India Private Limited, Mr. Sanjeev Kumar, Vice President, Business Line Manager, Automation and Digitalization, Sandvik Mining and Rock Technologies, India Private Limited, and Mr. Vinod Kumar, SBO Director, Hindustan Zinc and Vedanta. And I'm your moderator, Monica. To begin with, I would like to invite Dr. Mukesh, Director, Steel Research and Technology Mission of India, to please open the session. Dr. Mukesh, I'm unmuting your mic. I welcome you, sir.
Thank you, Monica, and good afternoon to all my dear panelists and all the attendees in the Underground Mining Conference. Today, I think this webinar, Underground Mining and Industry 4.0, is one of the webinar which is organized by MetaLogic, and I think in India, still that much focus is not there on underground mines. Although world over, in underground mines, use of Industry 4.0 and manless machines and machineries are being used, and big mines of 20 million ton, 30 million ton underground mines are being used with such equipment and facilities. India, although is a very resource-rich country, And but our main problem is still most of our metallic minerals and non-metallic minerals also are being imported in the country, and that's why a huge foreign exchange is outflow is there. The main reason of such condition is lack of focus on our exploration, because most of our areas, most of our minerals are still lying unexplored. If we talk about our total land area of around 3.2875 million square kilometer, that is the total area. Out of that, around 20%, around 5,71,000 is million square kilometer is an obvious geological potential area, where we feel that lot of minerals like aluminum, lead, zinc, copper, manganese, platinum, titanium, even diamonds, all those may be available. But it is very unfortunate that only around 10 to 15% of area, such area, has been explored. And in that explored area also, only around 15% area mining is going on. That shows the state of affairs where we have. In spite of our best advantage of having all the minerals, we are not in a position to encash this opportunity. Once upon a time, it was always considered that India, Australia, Africa, and South America was one continent. And geotechnically, we are linked with each other country. So the type of geotechnical formation which has taken place in this country is taking place, must have been taking place in our country also. And we feel that if we do more and more exploration, then these minerals which are hidden there can be explored. The main challenge is now how to go this thing exploration thing. Nowadays, advanced exploration techniques like 3D imaging, magnetic survey, all those things are being used for exploring deep-seated mineral or for concealed hidden mineral. Although the word deep-seated mineral is very, this thing sometimes people say, what is deep-seated mineral? Actually, in MMDR Act 2015, when they made amendment in 2020, they made it very clear that any mineral which is seated below 300 meter, Ministry of Mines consider those things as deep-seated minerals. And if we consider those deep-seated mineral, exploration has not taken place much. Most of our exploration which has been undertaken by Geological Survey of India or Mineral Exploration Corporation of India Limited, it has taken place maximum up to a depth of around 100 meters. It means a shallow depth. We have not touched that underground mining at all. In other countries like Australia, Canada, Africa, people, private companies, mostly they are engaged in your exploration activities, because exploration of deep-seated minerals is not only risky, but very capital extensive also. So whenever anybody wants to invest money in exploration, they want some guarantee that at least they should have access to those areas where they are doing exploration and other things. But unfortunately, we have amended our MMDR Act in 2015. And in MMDR Act 2015 also, we have made provision that if anybody is coming for exploration, they can come for exploration, but it will be a non-exclusive basis. And once it is said it is a non-exclusive basis, and after exploration, if you have to share all the data with the government, then nobody shows much interest. So last 5 years, hardly any detailed exploration has been undertaken in this area. Now government is considering a
Mukesh, sir, sorry, you're not audible to me.
things not being.
Sir, sorry, we lost you in between. We missed your last two lines. If you could repeat again.
A new subject in India. We have very, very old mines like Hindustan Zinc, Jawar mines is there. Hindustan Zinc is there. Bharat your Bharat Gold Mines is there. Hatti Gold Mines is there. Manganese Ore India Limited is there. Uranium Corporation is there. They are doing underground mines since long. But are we competent enough to undertake total underground mining job of our own? Starting from mineral exploration to the mine designing, to the shaft designing, to operation, safety, hazards, everything. Still, if you see, look into it, a huge gap is there. Most of the things we are totally dependent on external sources only. Even if we think for a shaft sinking also, in shaft sinking also, even if we want to go to 600-meter depth or 700-meter depth, which is not much, we don't have any company in India who can undertake this type of work of shaft sinking or shaft design or other ventilation shafts or any shaft. So that's why the time taking it takes a lot of time. I was going through one this thing reference that there was a copper mines. It was a case like Malanjkhand we are having. In Malanjkhand, we have gone to a certain depth where open cast was possible. And we were operating around 2.5 million. But there, we are now going to go to 5 million. That 5 million ton capacity we are planning through underground mines. And that job was given to a local contractor in which 4 shafts were to be synced. Service shaft, production shaft, ventilation shaft, those shafts were there. Job has been started in 2015, but still we are in 2020. So job almost, I think, not more than 40 to 50% has been completed. The project will be extended another 3 years, 4 years. Even we are using best international consultant also, that type of expertise we are using, and even then we are not in a position. But if we see same thing in other mines, like similar thing was there in South Africa. That is Phalaborwa mines, where 4 shafts up to a depth of 1290 meters were synced. And again, diameter was too much there. Some shafts were 7 meter dia, some shafts were 9.9 meter diameter, and all shafts have been made in a record time of around 4.5 years. Total project has been completed. So if we see from that angle, India, we have to make a lot of movement in this direction because our surface reserves, our surface minerals are getting exploited or getting depleted very fast. And today or tomorrow, we have to go towards the underground mines. And underground mines only will be the option. Whether today when we say that everybody look mining mainly iron ore, coal, which are generally open cast mines. Except few mines where coal, we also have underground mines. But other mines, if we consider like manganese, copper, as I told, lead, zinc, Hindustan zinc is one of the examples, or even you consider gold, you consider platinum, you consider diamond. There, I think we have to go underground. There is no other way where we can go. So we have to develop our techniques both in shaft sinking also as well as shaft deepening also. When we talk about the shaft deepening, again problems comes. I am again giving an example of Hindustan Copper Limited. K3 plant was there. They were to deepen extended the shaft by around 160 meters. And when they were doing, they have took a decision that okay, instead of sinking a new shaft, we will go with shaft deepening. And by doing just around 20-30% work, they found a big earth fault is there. And when fault was there, they have to suspend all the operation and the project was stopped. So what happened in this action when underground mines are there, the shaft is the only safe and reliable access. You cannot play with that. So whether it is a brownfield project or whether it is a brownfield expansion work, everywhere we have to see how best we can utilize our resources and how much additional technique or capacity has to be used. Utilizing latest techniques today's time is one of the most important, because there are shaft sinkers who can develop, who can sink shaft up to 90 meter or 100 meter in a month. But in India, we don't even achieve around 7 meter, 8 meter or 10 meter also. So new techniques are required. The way we are moving forward, load at load, underground mines are going to come up. So I think more and more opportunities are going to be created and more mines opening will come towards the underground because we are focusing on all the areas. I'm very hopeful that today's seminar, what we have organized, you people will get a lot of in-house, in-depth knowledge on various aspects of this underground mining operation. Whether it is high-speed sinking, shaft sinking is there, or high-speed cement lining is there, high-speed mechanized decline development is there, or whether it is mine development at main level, whether it is a ore body development, whether it is a ventilation system, whether it is a water evacuation systems, whether it is safety system. Today we have from IBM, from Sandvik, those are international players in these lines who have developed a lot of international best equipment, best systems, and best practices, which can be utilized in our country. You will get presentation from Hindustan Zinc Limited also. I think today it has become a reference point in underground mining in India operations. Whether it is a mining practice, whether it is a mining this thing, use of intelligent software, use of artificial software, whatever is you talk, Hindustan Zinc has become almost like a reference point for all the underground mines today in operation or going to be operation. I hope you will get a lot of in-depth knowledge about this system, and most of the industry will get benefited. With these things, I welcome Monica, welcome all the other panelists to take over and to start. Thank you very much.
Thank you so much, Mukesh sir. And before we move on to our next panelist, I'd like to raise a poll for our audience. So audience, please vote. I'm just starting the poll. Okay, so this poll is related to exploration. On your screen, audience. So the question is, exploration of deep-seated minerals in India, what is the main challenge? Is it technology or government interference and clearances, lack of funds, or lack of interest? Audience, please vote. What is the main challenge do you see in deep-seated mineral exploration? Is it technology, government interference and clearance, lack of funds, or lack of interest? Please vote. I understand this is winter and yeah, everyone's fingers might be frozen, but please vote before we begin with our next panelist. All right, so we have the results. Results on your screen. So the poll result says 46% of our audience feels that technology is the main challenge what we face in deep-seated mineral exploration. 34% feels that government interference and clearance is the second most challenge. 12% feels it's a lack of funds and 9% feel lack of interest. Now we know the answer that the majority feels it is the technology related challenges we are facing, and 34% feels the government interference is a lot. Now I'm moving on to our next panelist. We have set the tone. We have Mr. Biplob Chatterjee. A little introduction about Mr. Biplob. Mr. Biplob has 35 years of experience in the exploration and mining industry through career in Rio Tinto, Geological Survey of India, and Oil and Natural Gas Corporation. He is a co-founder of Geovale Services, which has been one of the most active consulting team in the mineral and water domain in India and other parts of the world since 2013. His team has executed a number of exploration projects, management resource and resource evaluation projects for coal in Indonesia, India, and iron ore, India, Oman, Malaysia, and for manganese, India, Philippines, and industrial mineral, India, and Africa. Over to you, Biplob sir, and I welcome you to this webinar.
Thank you, Monica. Thank you, Mukesh ji. Good afternoon to all of you, wherever you are. It's wonderful to be again a panelist here. This is about underground mining. The topic says, although Mukesh sir, you have already set the tone. Probably there is a scope for exploration as well when we intend to carry out underground mining in the framework of Industry 4.0. I'll try to give my views. Your poll also set the tone, Monica. People feel that it's technology which is the biggest hamper in deep-seated mineral exploration in India. People also feel almost an equal number feel government interference and clearance, and I believe both these factors are very, very critical factors as far as deep-seated mineral exploration in India is concerned. Now, since so this will be a very high level, I know that this is an audience which has sort of a different, which are from different domains. I'll keep it at a high level only, not go into great details of technical details of exploration. Well, since MMDR 2015, as Mukesh has already said, and thereafter NMP 2019, India has started talking about its deep-seated mineral exploration requirements. Now, the big premise is that India has potentially explored most of its shallow mineral deposits. Hence, only deep-seated mineral deposits are likely critical targets for mineral exploration. Now, we will test the veracity of this hypothesis here. It sort of means that there is all the shallow mineral deposits have been already explored, found out. Mukesh just said only 10% has been explored. But some part of the government says that all the shallow mineral deposits have been explored. That's why we need to look for only deep-seated mineral exploration. So we will look at what deep-seated mineral exploration means, and also we'll look at what does it take to carry out such exploration. Now, there's absolutely no established definition of deep-seated mineralization. And as you pointed out, sir, MOM considers deposits occurring at depths of greater than 300 meters at deep-seated, just for semantics, nothing more. Now, should we consider all underground mining proposition for deep-seated mineralization? Again, switching from an open pit to underground would entirely be the function of mineralization style and economics. That's why we have Bingham Canyon in Utah, in the Rockies, which is an open pit mine at 1,200 meters depth. Balanchkan, which is a similar porphyry, albeit of a different age, porphyry copper, is going for underground exploitation at from 300 to 600 meters depth, after open pitting for about 150 to 170 meters from the surface. Now, our understanding the generic mineral systems do not suggest that there is a real natural cutoff or depth control at which nature would start providing us bountiful of resources. Now, petroleum is an exception, though. We are not talking about that here. There are certainly deposits, especially supergene deposits, which have not been capped because of subsequent geological events that are most likely to bottom out, actually. They occur near surface and would bottom out. So the illustrations would include, for example, the bauxite deposits in the Eastern or Western Ghats, or the BIF-hosted hematitic iron ore in the Horseshoe Belt, Baladilla or Bellary Hospet, or Goa synthetic regions, or the barren manganese quartzite, the supergene manganese enrichment in the Horseshoe Belt, or the Valley Vilas Formation, the Dharwar Formation, Dharwar, Creton, or those of Goa. Now, on the other side, we have the hydrothermal deposits, sourced from granitic materials, which could go up to kilometers depth in a geological structure. Now, thermal resetting due to igneous intrusion or tectonic deformation too can occur at different depths to become causative for deeper level mineralization. But for us explorers, those fossilized thermotectonic zones with its mineralization do not get exhumed or get capped by subsequent by subsequent geological events. Now, most of the lode style or share-hosted gold deposits like Kolar or Hatti or Jonagiri or Ganachur and the other potential greenstone belt-hosted deposits, gold deposits, Dharwar, Bastar, or Singhbhum Creton, can extend down to great depths. Basement deposits too can extend down from near surface to great depths. Diamond-hosted kimberlites can extend to great depths, and many igneous source deposits could occur at significant depths. But the rule of the game is to try and recognize most of the mineralization signatures at near surface at an early stage of exploration before carrying out any depth prognostication. Now, subsequent geological events can actually cap a deposit, cover a deposit with a capping, and such caps could be of various thicknesses. Now, Western Australia supergene regular capping could be over 100-meter thick, which allows both geochemical and geophysical vectors for exploration. The Fort-Alaconne diamond deposits in Saskatchewan in Canada occurs over a glacial tail cover of more than 150 meters and allows only geophysical vector for a non-invasive prognosis. Now, in India too, we have parts of capped domains such as Deccan Trap or Proterozoic Gondwana sedimentary covers, or the Thar Desert, or peripheral regions of Indo-Gangetic alluvial cover, which could potentially host mineral deposits. The big fact is that most of these, with exceptions like Pachami coalfield or the shallower parts of Barmer Potash or Rio Tinto's discovery of kimberlites below cap cover in Chhattisgarh or Madhya Pradesh, have actually remained completely unexplored to date. So I don't believe, again, that exploration has been actually carried out, as Mukesh Kumar Sahab just pointed out. Because if we want to target deep-seated deposits, we have two routes to start. A route A would be to explore for deposit signatures from surface downwards, and then could be a route B to explore for deposit signatures below the cover rocks. So there could be an exceptional route C2 where Providence, God has decided to place a mineral deposit in complete isolation at depth without any discernible surface signature. Olympic Dam probably, and IUCG style mineralization could be such an exception. So what could be India's strategy to explore for deep-seated minerals? Now, to me, India has the best chance of finding its deep-seated deposits through Route A, meaning that we need to look for depth extensions of near-surface mineral occurrences. So again, find more near-surface deposits or occurrences and look for their depth extension through interpretation of geology, structure, etc., etc., etc. Now that should be a priority one. Priority two could be looking for mineral deposits through Route B, that is below the capping. Now, again, in such situations, we need to define the mineral systems and look for vectors which can then be used for exploration. Now, let us see some excellent illustrations of Route A from of use of Route A from India, that is exploration deeper seated deposit, which are depth extension of shallow deposits. Our legacy of Kolar Goldfield that has demonstrated that relentless pursuit of deeper extensions of the deposit. That's a fascinating example. And in our recent times, again mentioned earlier, Hindustan Zinc Limited, we are going to hear Vinod Kumarji for sure. Post-2003 acquisition by Vedanta has demonstrated the value created through brownfield exploration by almost trebling its geological resource at Rampura Gucha, and now world's largest, I believe, and also converting Sindhesar Khurd into a world-class tier 1 lead zinc silver deposit. Now, I understand you are planning to go ahead with a similar strategy for your other assets, Vinod Kumarji. So HCL has now decided to extend Malanchkan into underground development from 300 to 600 meters. HCL's other mines too have significant brownfield potential for additional resource. Hati, currently producing just 1 to 1.5 tons of gold per year, has great potential for depth extension. Mukesh Kumarji mentioned Moil, UCL too. All of their assets have brownfield deeper extension potential. I would point out something here. It's noteworthy that all these government PSUs, Hindustan Copper, Hindustan Hati Gold Mines, Moil, UCL, have near monopolistic dominance over large asset base of the commodities. And in all these commodities, India has a significant import bill. Are we going somewhere wrong? Now, let's get back to it. As far as Route A for finding deep-seated mineralization is concerned, a significantly larger potential exists in the greenfield exploration arena in India. We've already talked about that. Now, to me, after having been part of top-level exploration teams and projects in many parts of the world, I strongly believe that India is one of the few last unexplored regions in this planet. 90% of our obvious geological potential. Now, Mukesh Kumar Sahab, you said only 0.5 million square kilometer. For us, it's 2 million square kilometers, 4 times that, which is our obvious geological potential, is grossly unexplored. Because we need to prioritize the investigation for our shallow deposits before we start focusing on their depth extension. Now, Route B, exploration potential below cappings too has excellent untapped potential in India. So, for example, in Norilsk style chrome nickel deposit is possible below Deccan Trap. Met coal is possible below Gondwana extensions, similar to what we see below Rajmahals in West Bengal in the Pachami field. Potash deposits with solution mining potential is possible in the downthrown western block of the Barmer Basin below Thar. Diamond deposits are also possible below Upper Vindhyans and Kannur sediments. Rio Tinto, our team showed that. These are just a few illustrations to indicate that we haven't even attempted to explore some of these excellent deep-seated mineral potential. So where are the technology gaps in the deep-seated mineral targeting? Most of our non-bulk mineral targets have been based on closology or brownfield approach around the old working and looking for extensions. However, the next phase of mineral targeting would require a more detailed definition of our mineral systems. Now, we have spectacular geological, structural, geochemical, and potential field radiometric and geophysical data collected by GSI. It's world-class, absolutely, I must tell you. I'm in sort of awe of the data collected by GSI and the capability of doing so. And more is being collected, I must tell you. Probably we now need an emphasis on collection of many, many more geochronological data. That's missing. We need age data. As Australian Geoscience has been showcasing in their project Uncover, which they're also collaborating, which they're doing in Australia, as also collaborating with GSI here in India. We need to integrate all these regional and available mineralization data sets to develop a better definition of mineral systems in the framework of crustal events. Now, there are many innovations happening towards creation of new exploration tools. And some of those have been, we have already just mentioned some of those 3D tomography or use of artificial intelligence in large data analytics, etc., etc. Now, these exploration tools range from predictive mapping through high-resolution remote sensing data sets, from multispectral to hyperspectral, gravimetric aerogeophysical data acquisition, potential field geophysics. Drone geophysics will be invoked soon for detailed exploration, newer methods of geochemical sample processing. New methods of data collection, analysis of electrical and electromagnetic field, etc., etc., etc. Drilling, as we are collecting more and more of high-resolution data, again, software capabilities are showing remarkable improvements. Again, I'm sure Vinod Kumar will probably mention about this. HZL has pioneered the use of many of these tools illustrated through their brownfield exploration results of both Rampura and Sandvik deposits. You have used directional drilling, downhole geophysics, and automated logging. We are aware of that to interpret your massive data sets to excellent results. Now, Dr. Devarajan, who is now exploration head of our team in Geovale, and his team collected oriented drill cores. Again, a novelty in Indian exploration scene to map out gold-bearing shear zones at great depths in Jonagiri to
Biplob, sir, sorry to interrupt, sir. So you would need to conclude in 1 minute, sir.
Sure, absolutely, Monica. So Rio Tinto Bandha team carried out interpretation of microdiamond fusion results and innovative geostatistical tools to assess the diamond resources of Bandha deposits to more than half a kilometer of the surface. Let me get to conclusions straight away, as you suggested, to Monica. So India's strategy and goals for deep-seated mineral targeting should be simple. And this is my 4-step mantra for this. A, reverse the current lack of investments in the greenfield exploration, mineral exploration in the country, encourage and statutorily ensure and compel asset holders for brownfield exploration of potential deep source mineralization of their assets. Now, open up GSI's entire digital baseline database for global explorers to evaluate while creating a globally competitive mineral investment code for extensive domestic and international investment in India's mineral exploration. Allow freedom for area selection for greenfield exploration in any part of OGP after blocking out the no-go areas. Number 3, remove evidence of mineral content rule from very specific, remove evidence of mineral content rule from MNBR 2015 and allow mineral assets to be carved in a way to enable brownfield exploration as well. And number 4, GSI and MOM must either facilitate private exploration investments or themselves carry out exploration under various cover stratigraphy to unravel the deep-seated mineral exploration potential. Thank you very much.
Thank you so much, Biplob, sir, for explaining so deeply about brownfield and greenfield projects. And technically, yes, Hershey and Sanjeev ji will take it over. Now, before moving on to our next panelist, audience, let's have another poll. So let's get started. We have a new question on your screen. Where do you see Indian mining and exploration industry stands in adopting Industry 4.0? Audience, please vote. Where do you see Indian mining and exploration industry stands in adopting Industry 4.0? Your options are very active in adopting, depends on the project, less interested because of cost and other factors. Other factors could be anything. So, yeah, so here are the results. I'm closing the poll. Please be active, stay active, because I won't be able to give much time for voting. All right. So we asked a question, where do you see Indian mining and exploration industry stands in adopting Industry 4.0? So majority has gone to 48% on depends on the project. 32% says less interested because of cost and other factor. And the lowest has gone to very active in adopting, which means, yes, there is a scope when companies can really look forward in adopting Industry 4.0. And with this, we will move on to our next panelist. We have Mr. Harsh. A little introduction about Mr. Harsh. Harsh is IBM Service Distribution and Industrial Sector Partner and Executive Director for India and South Asia. Prior to taking this role in January 2016, he has been the lead account partner for a leading conglomerate for the Asia Pacific region and GBS Natural Resource Cluster Leader from India. He is currently focused on digital reinvention, including Internet of Things, blockchains, and IBM's cognitive and AI solutions in these segments. I welcome you, Mr. Harsh Kumar. Over to you.
Thank you.
Shall I make you a presenter to share your screen?
Yes, please. Is my screen visible, Monica?
Absolutely, sir. It is visible to us.
Okay, thank you. A very warm good afternoon to all ladies and gentlemen on in this event, and thanks to be part of this August panel with such esteemed speakers, Mukesh ji, Biplob ji, and Sanjeev ji and Vinod ji, who are there, and they are actual practitioners. So my objective of sharing is a point of view as to how platforms and data platforms are actually shaping the mining industry and how they can be used in underground mining and others. I think they will share exactly how these concepts, which I'll be covering, are actually put to use. Sandvik and the examples which you will see in the Hindustan Zinc, they actually are live examples of the various elements of Industry 4.0 platforms which are being covered. Just to give a quick brief introductions, and all of you who are there in this webinar definitely know this value chain, supply chain, the overall from a mining perspective, and the various, you can say, application platforms or system platforms which are existing, which help in the process as well as managing the operations. One of the main pillars which is coming in over is the automation of these activities which can be done, or how best you can activate the operations. Now, from a people and process perspective, if you see at the top end, these are the various work streams which are existing. You are very well aware of that. And coming from the natural resources, in particular mining industry, obviously safety is one of the prime objectives of any initiatives. And there are initiatives which various firms across the globe have taken under the Industry 4.0 ambit using the latest technologies which are available, and that cuts across. I mean, you could talk about security elements, which could be physical, cyber, or you could be starting with AI and analytics, getting into automation, looking at IoT and edge devices, and also blockchain and hybrid multi-cloud. So these are actually facilitators. And if I were to just go back to the two poles which happened, technology was called out as one of the elements. And the second was why Industry 4.0, it depends on a project, yes. And I think I'll definitely concur with the audience poll. A business case has to be proven. A business case will decide as to what platforms, what use, but earlier what could not be feasible is now actually very much feasible with the tools and the elements which are there. I may not be delving so much into the mining industry technologies, but a lot of that equipment performance, the processes in the mining industry in particular, or whether we are focused only on the underground as this webinar is, you can actually transform. So the way we see the entire mining industry, we see it in four distinct dimensions. It's how transforming. A lot of us have seen earlier is the transform enterprise. But there are other elements which are actually moving on, which is transform operations, transform products, as well as transform experience itself. Now, experience could be from a worker experience, could be from your ecosystem, a partner experience, transform product in terms of your over-identifying, improving, and operations. I think I will not cover so much into operations because there are two very esteemed speakers who are coming immediately after my session, and they will actually cover how these platforms and these technologies within the two organizations and how they are taking it to the various mining industry. But just to cover like an element which Biplob ji talked about, we have actually seen how core body discovery through the use of these technology and platforms in the global, it's really made massive amount of improvements. Asset performance, health, safety, yes, these are very, very important elements. And asset performance, whether we are talking about dumper performance, whether we're talking about equipment performance, can you have predictive analytics, and to make sure when somebody is operating those equipment, he's not put at, you can say, risk, or the operations are not put at risk. Both the elements actually are deployed and active in various mines across the globe. So one of the key elements which these technologies are enabling is the intelligent workflows. Yes, the pivots are around the edge IoT devices which collect the information, AI engines which can actually interpret or understand and use it. Can you have a platform which is cutting across your entire ecosystem so that the information goes across? This is where blockchain technologies come in play, and then obviously the overall automation of this. And there's a lot of work which has happened, and I'll cover through some of the specific use cases from across the globe also in that perspective. Most of these work streams definitely can be further improved, and that's our biggest point of view, which we have seen. And examples not only from the mining industry, but the wider natural resources, which is from the oil exploration and other areas also, they are using it. So if I were to just take you through the various, you can call them value chain accelerators, but if we were to just look them from the left to the right, the various improvements, and from a top to the bottom, some of the examples, if we were to just talk about, like if I were to talk about the cognitive ore body work, which has actually been done, and you can see, if you're not able to read the KPIs, I can help you with that. An improvement with respect to 95% geo inquiry time and 20% prospective plan on predictive block models. That is a published case study which of the work which we have done with Goldcorp in the North America and also in other regions also. From a traceability, if I were to just take one example of tracing, then you can say one of the prime examples which we have done is tracing the cobalt which gets used in automobile, and then to trace it back to its origin and authenticity, so that it's not a conflict mineral which is being transported across the transcontinental supply chains. That's where you have technologies like blockchain and other platforms working in a combination with various others being worked and cutting across the last end consumer, which is the auto industry and the exploration and the mining industry. So those are a couple of examples, which is you can say from a supply chain and the ecosystem, or the wider ecosystem which we are covering. If we were to just take, as we talked about, transform operations, the predictive analytics and the equipment maintenance, I think there'll be a lot of examples which would be covered. But to go specifically on safe to work, we have deployed and we have seen these solutions, which are wearable technologies, which can identify the person's, you can say the body temperature, the heart rate, the pulse rate, as well as you can say whether he's moving, motion. These are basic wearable technology, which most of us actually see it in our use. Some of you would be using something like a Fitbit or a smartwatch or something like that, but these technologies getting used at the worker level, which are robust enough and at the same time can work in those low connectivity areas to ensure that the safety and the worker elements come in. Yes, those are regular improvement areas as to how you can optimize your inventory or how can you optimize the supply chains. Those work also have happened. But these are some of the examples which I thought I will share, and these cut across, you can say, both from examples are from Australia, from an iron ore, when we are talking on mine to port, their entire transshipment, or if we are talking about, you can say, trading, which is a complete industry platform where almost players from my financials, the logistics players, as well as the mine players, all have contributed to ensure that the entire ecosystem works across. Very, very clear. With respect to logistics, yes, the entire platform actually, along with IBM and Merck's, we are tied up, which is known as the trade lens, which is covering the entire gamut from, you can say, the sourcing from the ports, transshipment, and then across, and with all the players are there. So that's one major thing. And there are tie-ups in India also, which are there. And just probably to lay the ground for the next speaker, specifically with respect to, you can say, the equipment productivity and its health, we have partnered with Sandvik and into one of their major offering. So the way we see the industry 4.0 come forth is from two dimensions. These platforms are enabling a transformation of the mining industry, either from a operator of things or maker of things. That's how we see the entire ecosystem getting impacted. So either the technologies or these improvements are being used by maker of things, which is like folks like Sandvik, who make the equipment, deploy it, and they can churn out new business models, or an operator of things. If you're using contracted equipment or you're operating out there, then you want to probably analyze and ensure that the operations are smooth and transformed with improvements. So that's another aspect of there. So these are some of the, you can say, from a mining and a value chain as to how Industry 4.0 examples, both from an equipment health, or you can say how these technologies are actually being used in an ecosystem play, or you can say how you are improving your exploration capabilities, or your regular safety operations, how you're ensuring your employees are well covered. Are there examples? I think India examples will be well covered. What I have given you is a flavor of the global examples, right from Americas to Australia and across the globe. So that's all right now for the time being from my side. Thank you. Over to you, Monica.
Thank you so much, Hershey. First of all, I'll just make it easy for everyone and you. Okay, so moving on to our next panelist. Thank you, Hershey, for giving us a great presentation. Before we move on to our next panelist, we have another poll questions. Audience, on your screen, please vote. Does Industry 4.0 helps in resolving the issues related to miners' safety? Yes, no, depends. Does Industry 4.0 helps in resolving the issues related to miners' safety? Audience, please vote. On your screen. So despite of this cold, our audience is very active in voting. I can see number is increasing like anything. Does Industry 4.0 helps in resolving the issue related to miner safety? Yes, no, depends. So here are the results. On your screen, 67% people feel yes, it does help in miner safety. 5% feels no, 28% feels depends. Now we have our next panelist, Mr. Sanjeev Kumar. A little introduction about Mr. Sanjeev. Mr. Sanjeev Kumar, with more than 23 years of experience across industries, mining and construction equipment, metal, steel, etc. He is an expert across functions like international trade, domestic sales, commercial management, process and business excellence, presently heading automation business in Sandvik Mining and Rock Technology India's Private Limited. It involves implementation of Sandvik digital offering in mining industry, which includes connected equipment, process optimization tools, and autonomous running of equipments using AutoMine. I welcome you, Sanjeev ji. Over to you. Please unmute your mic.
Yeah. And can you please help me share the screen?
Sure. So I'm making you a presenter. You will get a message on your screen to share it. Please keep your
Yes,
PPT
please.
open.
And please let me know if you are able to see my screen.
Yes, your PPT is visible to us. Absolutely.
Good. So once again, good evening and a warm welcome to all of you. And thanks to entire panelists here, Monica, moderator, as well as the entire team helping us and listening to us, and opportunity to share some of our feedback. What I will be today covering around will be on the underground mining industry, what the role digitalization and automation is offering globally as well as in India. Safety first. Hope all of you are in safe location and you are aware of your emergency exit. And also in the COVID time, we are all going through a very tough pandemic situations. And we should not let our guards down, even if when we go out, we see that the data statistics showing that recovery rate is improving. But here, one life loss is 100% loss to that entire family. So please follow all COVID guidelines, protocols, and stay safe. What I will be covering here briefly would be a snapshot of my understanding and what today 4.0 is. What is digitalization? Why digitalization? And what are the Sandvik's offerings? And how it is being implemented in India as well. So yesterday also I was trying to look at why 4.0, and we have been talking about 4.0. I went to see, okay, it was the invention or understanding from our German friends that it started with steam, then we moved to electrical. 90s was, we all know, era of electronics and IT, and today we all of us know we are talking about internet. So this is the fourth industrial revolution that we all are talking about, Internet of Things. So today we are talking about everything on the cloud, accessible for all locations. We will not be sitting in office, which we have in fact seen that helping a lot during this pandemic time. And then we are talking about today decision making from sensors to the boardroom. So now today the decisions are taking based on the ground level data flowing directly onto the decision makers table. So in mining 4.0 concept, we are today, the world is looking at about all the digital mine. When we are talking about digital mine, it is talking about in not only the underground mining operations, but associated operation as well, be it smelting and be it mill and beneficiation and entire value chain. But if I restrict it to the mining, then we are all talking about the connected mine, connected people, connected equipment. And what is making it happen today? It is the underground mining infrastructure, which is now also taking a lot of investments and thinking about from the people. Wi-Fi networks is becoming need of the hour in a lot of the mines globally. In India, we also know Hindustan Zinc has gone way ahead and implemented this underground mine network. And even Nokia have partnered with Sandvik and other companies to work upon this 5G technology. Then, as Mr. Harsh pointed out as well, today we are all not only restricted it to conventional way of maintenance, but more and more we are moving towards data-based, information-based systems for maintenance and going a step ahead from becoming preventive maintenance to the next level of predictive maintenance. Then mine is today being supported by technology. Miners have got there a lot of facilities today, which we have seen in terms of people tracking. We are talking about various alarms and signals in the equipments, which are helping the operators as well to take up preventive actions of shutting down the machines. We are talking about autonomous machines today, which is about running it from surface or from a distant places away from the actual working area, under the stoves, or maybe today it can also be done from few kilometers away. And last but not the least, about the people, training skill is more important. And so we are seeing not only hands-on training, but it is also happening the simulation. Simulators have been set up, and virtual reality is a methodology also being used for giving hands-on training to the new people, the new team which are coming on to manage these equipments. So what the digital transformation in mining is talking about, it is about safety to begin with, because unless and until, like any other mine, we get the confidence of the people of the safety and the improved work conditions, it will then translate definitely into the productivity, and at the end of the day, the goal is profitability. So why digitalization? Again, the takeaway from this point is that exposure to the hard working condition in underground, which we are talking about, we know how the conditions people are working in today, and that is more important to ensure that they are connected always and visible at what point of time where they are. And we are talking about the transparency in terms of operations, connectivity of information flow from underground to the surface, which will ensure better utilization and availability of the equipment. And at the end of the day, will help you improve the productivity by improving the cost base as well. So which we have seen is, like, for example, autonomous running of equipments. We have seen that here you will find that conventional method, and then over there has always been improvement on the production when there is a information based decisions are taken based on the data analysis. And today, when it is a totally complete autonomous running of machines, when the machines are working like robots, when they are teaching is done to them, for the pre-machine learning system is given to them, and then the repetitive task can be done by them on their own, even if the mine is not available for people to be there, like in the blasting and during the smoke hour operations. And it has an impact on the lost time injuries, which help you save the people health and safety. So in Sandvik, what we have been playing or offering is about connected equipment, which is, I'll talk a brief about it. Then Optimine, which is a tool which we have deployed in Hindustan Zinc Limited mines, which is talking about process optimization and the maintenance analytics. And then we are also talking about advanced features, more intelligent machines, and autonomous running of the equipment. When we talk about MyDynamic digital services, it's about connected fleet where the data can be seen on the dashboard. Any analysis, parameters of productivity, utilization, be it the machine's performance in terms of the alarms they are raising, the signals which are coming, which will help you to do various maintenance related practices, keep on monitoring the performance, and also based on the database of the connected equipment across the globe, which will also help you to set up your benchmark practices to improve your day-to-day working. And when we are talking about Optimine, which is more about a process optimization tool, which is about tracking people and also providing you with the short interval control, as we call it, that is between the shift operations monitoring, so that you are able to bridge the gap, minimize the losses, and improve upon the utilization. And all these input, if you see, goes into this analytic platform, which is then being held by players like IBM to develop the platform where the predictive model comes into the play. So what happened here is, if you see in the location tracking, you are able to track equipment and the people, which will help you give your transparency, safety, and obviously improve performance. Then there are movement of communication of shift in between tasks, communication of scheduling of the shift and the task management, which is deployed at the SK mines, which is in quite good usage now. People have started practicing the usage. And then what is happening is that all this will boil down to, apart from safety, improved utilization and the production, or we call it as overall equipment efficiency, or OEE. So analytics, when we talked about it, is primarily a sort of a descriptive also, which talks about, they give you various KPIs which you can monitor in terms of utilization, availability, production numbers, performances. And for equipment, it's talk about the prediction part of it, where the key components have a probability of failure which come up on the dashboard. Based on that, the maintenance team takes the action and is able to take a corrective action in advance to avoid the failure. So those are some of the key components which have been built in this predictive model, which is being used for loaders and trucks in SK mines, and which is being used for planning the maintenance and improve the life of the machine. So if you look at this slide, this is a snapshot of how a control room view is there of equipment and mine people tracking. If you see here, these are like a network access points, and the truck moving you can see today on the live basis in the mine control room. And you can also see where which people are located, and that can be contacted and reached at any point in time, subject to the network availability. And on this side, if you see a trial which is going on, which is primarily a traffic management tool, wherein an operator, a truck, has got a tablet, and this will help him to plan his movement and manage the traffic better to improve the productivity and the utilization. So that was the tool which talks about how other equipments will help truck to improve their cycle time, give pass to the priority vehicles, and then they also see on their map where is the next bypass where they can park that and allow the high priority vehicles to move. This is the trial which is going on in the SK mine. Coming to the other module which we have talked about is AutoMine, and this AutoMine we are talking about is autonomous running of machines. Today, for example, we are running drill machines, which we call DL421 solos, which during the smoke hours, that is in between the shift change when the blasting happens and people have to evacuate, and that continues to run from the surface. Here you are seeing also the application for loaders and trucks, where there is a variant of these modules which can be like a semi-autonomous, you can say, which is a tele-remote, which has to be a line of sight. And then there are variations of fully automated trucks and loaders, where it is talking about one machine at a time, more than one machine in more than one locations, and more than one machine in the same locations. So these are what it is prevalently happening around the globe. We have also tried this in SK mine for the loaders, which we will plan to restart again. Coming to the surface drill, recently Sandvik has also launched the AutoMine for surface drill. And this is the concept, and this is how it looks like. So this is talking about the autonomous running of the machine. So if you see, this is a van, there is a mobile station from where you can operate more than one rigs at a time. So it gives safety, no doubt about it. It also aligns, there are a lot of technical features built in for the machines, which can be preset, pre-programmed, and then machine keeps on again become more intelligent as and when the remodeling is done. so that what happens is whatever the learning comes is fed back to the system, and the remodeling of the system is done so that the machine becomes more and more intelligent. And the next part for the future which we are talking about is the sustainability. We all know is one of the key areas today for our environment, and everybody and each and every organization is moving to contribute to the betterment of the society and the environment. And Sandvik has always been one of the key and leaders in this one. And we have also come out with the battery electric vehicles and electric loaders. These had been recently launched, and some of the models are under trial. For example, Artisan is a partner which has tied up with us, and we have now started some trial lot with one of the customer in US. And similarly, this has been launched, and there will be soon the commercial and the deliveries of this will start worldwide. So in summary, what we are talking about is our combination of various parameters. If you are talked about, I spoke about my Sandvik, which we are talking about my connected fleet. We are talked about the Optimine, which is about making your in-shift optimization. Then there are partnership. We have got a partner of our Sandvik partner of Nutrax, which provide a lot of IoT devices, which are like people tracking, equipment tracking, and it can also be work with non-Sandvik, and non-Sandvik and Sandvik machines today can work together. So we are OEM agnostic. Then there is also Exin Technologies, our partner now, which is talking about autonomous drones and going into the difficult areas to do the scanning and taking about all the details. And Optimine is about, as we spoke about, the auto. So a lot of things are happening, and out of that, India has also started, and one part of that, as we spoke, we can see that active specifically around the Optimine and Autonine in our SZL SK mine. So gentlemen, coming to my last slide, I won't take much time. So this is a control room of SK mine. I mean, the final control room is finally taking shape, but this control room present today, if you see, is the live, which is happening today. And to end with the third, I will run a small video for betterment of the team. And just I will play this for so that.
It takes the guesswork out of men fear equipment and operations. Sandvik optimize analytics and operations machines for useless technologies on resources and info. Sandvik Optimize. To make the most of your mine's resources, know the facts, and unleash your insights.
Thank you, everyone. Thanks, Monica. Over to you.
Thank you so much, Sanjeev ji, for this detailed presentation from your side. And we are moving on to our last panelist, and Mr. Vinod, the Hindustan Zinc is the example which we have been talking about since yesterday, in fact. But before we start, I like to raise one more poll, if you allow. So this poll is, audience, on your screen. We have, what is the main challenge faced by underground miners? What is the main challenge faced by underground miners? Your options are connectivity, fear of accident and ventilations, lack of technology and automation. Audience, please vote. What is the main challenge faced by underground miners? Is it connectivity, or is it fear of accidents and ventilations, or lack of technology and automations? What is the main challenge faced by underground miners? So we have the results on your screen. So the majority, actually it's almost like a tie. 43% feels fear of accident and ventilation, 43% feels lack of technology and automation, and 14% feels connectivity. So moving on to our next panelist, we have Mr. Vinod Kumar. A little introduction about Mr. Vinod. He is a BTech and MTech in mining engineering with first class certificate of competency from DGMS. He is an accomplished senior mining leader with significant experience in open pit and underground hard rock mining, mainly at Hindustan Zinc Limited, a subsidiary of Vedanta Limited. During over 22 years of engagement with Hindustan Zinc Limited, he has contributed significantly towards the growth of Rampura Agucha mine and the company as a whole, and in the process of acquired valuable experience and skill to provide overall leadership and direction to the business functions owing to his in-depth understanding and hands-on experience of operating management, operating planning, geotech, project management, technical due diligence, short and long-term mine planning, strategic planning, stakeholders management, and overall business planning. He has exposure to some of the largest and most advanced global mining operations across Australia, Indonesia, Zambia, and Italy. I welcome you, Mr. Vinod, and I am unmuting your mic. Welcome to our webinar. So over to you.
Thanks, Monica. Thanks to all the panel members for really giving us the insights around various facets of mining industry. A very good afternoon to all the participants. So we have talked about the mining policy, exploration, then use of technology, then digitization that is happening in real life at Hindustan Zinc Limited. I will try to cover a few of the things that Sanjeev ji has talked about digitization and use of advanced technology. But before that, I will try to touch upon an important aspect of underground mining, which is backfilling. Why I wanted to talk about this topic is because this is one of the most critical field which I feel going forward is going to help mining industry in terms of improving safety as well as maximizing the recovery, which is scarce. So talking about backfilling, this is not a new subject. It is happening since the beginning of mining in terms of dry fill, then it moved to hydraulic sand fill. We used to see in coal mines, then cemented rock fill, and now the latest addition is paste backfill. So in dry fill, basically what we used to do, we used to just fill the voids with sand, gravel, and other rock waste that was accumulated during the mining operation. In hydraulic sand fill, we pumped classified mill tailings or naturally occurring sand deposits to the underground voids. In cemented rock fill, a mixture of rocks of various sizes along with cement gave a good solid ground to basically mine out the remaining portion of the ore or mineral. In paste backfill, what we are doing is we are basically using our tailings after basically thickening it. and mixing it with cement and using it for maximizing our safety and productivity from the mine. And why we have chosen at Hindustan Zinc to go with this paste filling technology is I just wanted to brief the audience about the background, because safety was our prime concern when we started to go underground, especially at Rampura Agucha mine. There we had some instances of weak ground where we were not able to control or manage the extraction safely. At the same time, we were not envisaging very good recovery. So by doing paste filling at Rampura Agucha mine or at other mines of Hindustan Zinc Limited, we have not just improved safety, but at the same time improved the recovery. So this slide just talks about the brief on the process of paste filling. So mill tailing at 45% solids, it is going through thickening and filtration to 84% solid. Then it is being mixed with adequate cement, varying from 6% to around 12%, which is getting converted into paste, and then it is pumped to the underground voids. At Rampura Agucha mine, we have got a network of around 10 kilometers of pipelines laid across different working areas in the mine, to which we are filling all the voids. We are working under the paste fill, that is engineered rock fill, and this is giving more confidence to the mining engineers and miners as compared to working under a in situ rock. So these are the tangible benefits, as I talked, improving safety, improving recovery, better utilizing the land in terms of we are not basically putting these tailings at surface, we are putting it underground. So land requirement at the surface is getting reduced. These are some of the intangible benefits. So this slide talks about that. It is in alignment with sustainability goals of Vedanta, which says zero harm, zero waste, and zero. Can you please share the screen? Am I audible? Yeah, am I audible?
Yes, we can hear you, Vinodji.
Okay, thank you. So I have lost my screen actually. Yeah, now it's there. Okay. So these are some of the challenges that we face during implementation of this backfilling project at Hindustan Zinc Limited. Owing to this large distances to be covered, low utilization of paste fill plant, raw material availability and utilization, reduction of operational breakdowns, high operational costs, and in the process we solved it. And one of the interesting basically use of paste backfilling that I wanted to discuss with the audience is, recently we interacted with our colleagues at Tata Steel, where they are doing high wall mining, and there they wanted to extract the remaining pillars which is left after high wall mining, and for that they were searching for some techniques to backfill the voids that were created, and after that extract the remaining pillars. So we interacted and we gave some concepts to them, and they are working on those concepts to further maximize their recovery. So this technique has, as I talked, replication potential across industry, and this is going to benefit the mining industry in terms of stability of the mine, increase in production cycle, safety of mine and tailing dam, increasing recovery of water, and maximizing use of tails in backfilling. So this slide talks about some of the basically practices that we shared with industries. So at Hindustan Zinc Limited, we have got paste fill operation at SK mine, Rampura Agucha mine, and recently we have commissioned at Jawar group of mines. So all the mining operations are running with backfilling with the objective of maximizing safety as well as improving overall recovery of the mineral. So this is the plan going forward for 1 year and more than 1 year. So this is a practice which is going to continue at Hindustan Zinc Limited, and I envisage that this practice is going to be adopted at many other mining companies for maximizing recovery of the mineral. So these are some of the best practices and use of advanced technology which is being adapted at Rampura Agucha mine in various unit operations, starting from safety, then management of machine to reduce man-machine interaction, accelerated UZ exploration, accelerated mine development, stope charging, so use of bulk emulsion explosives. I think Sanjeev ji has talked a lot about the digitization drive that has been happening at Hindustan Zinc Limited at Rampura Agucha as well as SK mine, and these two mines are really the reference mines, not just for Indian mining industry but globally, where you can see the digitization and use of advanced technology that has come up, whether it is in terms of improving the overall cycle time of hauling fleet through use of Wi-Fi network underground. So what we are doing is we are getting the machine position, not just machine position, but other productivity parameters like total payload, other equipment health parameters to get real-time data of all the equipments, and then analyzing it and putting it through our analytics to get maximum benefit out of it. So these are some of the other areas where we are using advanced technology, simulators for operator training, automatic equipment, washing facility, equipment health tracking, emergency management, cavity monitoring system to basically see what is the void created after mining, whether it is in conformation with the plan that we have prepared or not. Accordingly, next cycle, what action to be taken. So all these things are being used, and that can be replicated across mining industry. And in the beginning, Dr. Mukesh Kumar talked about shaft sinking and raise boring. So I would just like to mention something over here that Hindustan Zinc Limited has adopted advanced technology in raise boring, which is far productive as compared to the previous methods of raise boring through drilling and blasting, and it has really expedited the rate of progress that has been achieved at Hindustan Zinc Limited. And going forward, the world is looking at technology where raise boring can be utilized for shaft sinking as well, because it has got a great potential of expediting the vertical rate of development. So already experimentation of plus 7.5 meter dia raise boring is happening in some of the operations in South Africa. So once that is proven, then definitely it is going to be a breakthrough in shaft sinking technology. So thank you, and whatever questions come up, definitely I'd be happy to answer.
Thank you so much, Vinod sir. With this, we are starting the question and answers. So we are missing out Mr. Harsh, and I'm sure the other panelists will be able to answer the question on his behalf. Harsh will be joining us in some time. He's stuck at a meeting. So now we are starting the questions. You can all unmute yourself because the question will be one after one. You can answer. Before that, I'd like to raise one more poll to our audience. Audience on your screen. So the question is, clearance for underground mining, will it be easier than conventional open cast mining? Clearance for underground mining, will it be easier than conventional open cast mining? Audience, please vote. So your options are yes, no, unsure. Clearance for underground mining, will it be easier than conventional mining? Yes, no, unsure. So here are the results. So we have 44% feels yes, 49% feels no, 8% feels unsure. So we have this question for Biplob sir. Is there any plan to go beyond 4,000 meter for gold mining in India? As in South Africa at present, right now the situation is not good. When we talk about gold utilization, it appears our production is about 2 tons, but consumption mostly for ornamental purpose is about 700 tons. This question is from Dr. Singham Jaya